So we're almost done with this problem. Now we just want to graph our function. So we're given some pretty key points here. We have our y-intercept, and we also have our vertex. So if we wanted to graph our y-intercept first, I scaled my y values by 5s. So we know at 0, 34.5, we're going to have our y-intercept. So if I count 5, 10, 15, 20, 25, 30, 35, right below it, we're going to have 34.5 for our y-intercept. We also know that our vertex is at the coordinate 14, 10. We can also figure out our axis of symmetry from our vertex, since we know the axis of symmetry always contains the vertex. So we know that at x equals 14, same x value as the vertex, we're going to have our axis of symmetry. Scaled my x values by 2s, so if I count 2, 4, 6, 8, 10, 12, 14, right here we're going to have our axis of symmetry. Let's go ahead and draw a dotted line there. Then I can go ahead and graph my vertex at 14, 10, so my y values are scaled by 5, so 5, 10. There's my vertex. If we also look, just comparing to the context of the problem, so my vertex is less than my y-intercept, which makes sense because we know that our graph is going to have a minimum as we found in part A. And then lastly, we need one more point to graph, so we know that the axis of symmetry splits our parabola perfectly in half, so we know that our y-intercept is going to be reflected to the other side of the graph across the axis of symmetry. So we know that this is 14 away, so if I count 2, 4, 6, 8, 10, 12, 14. So here at 28, where is that value? 2834.5 is going to be our third point. So then if we connect our points, we're going to have our parabola. Not perfect, but you get the idea. There we go. So that's our parabola. So do we draw an arrow here, yes or no? So if we look here in the context of our problem, we are looking at the electric consumption for Gotham City from noon until noon the following day. So we know that that's going to be 24 hours. So I just said before that the x-coordinate of this point here is 28. We know that to the axis of symmetry is 14. If we're going to reflect it over the axis of symmetry, it's going to be the same distance from the axis of symmetry, which is 14 more. 14 plus 14 gives us 28. So this coordinate is 2834.5, which is out of the context of our problem. So we're not going to draw an arrow because we are only concerned about 24 hours, which would be 2 less. So around here is where our parabola would stop in terms of the context of the problem at this point. But that's just getting into the nitty-gritty. Just wanted you guys to graph the parabola, but also understand in the context of the problem. Also, you'll notice that we don't have any x-intercepts. We are above the x-axis. If I wanted to prove this algebraically, we know that when we find x-intercepts, we are going to set the function equal to 0 to then solve for x. So if we set our function equal to 0 of 1/8 x minus 14 squared plus 10, first thing I'm going to do is subtract 10 from both sides. We're doing the opposite of order of operations. Then we're going to multiply both sides by 8 to get rid of our fraction. We wind up having negative 80 equals x minus 14 squared. If we were to take the square root of both sides, you'll notice we have an issue. Cannot take the square root of a negative number because any number times itself is going to give us a positive. So we can never take the square root of a negative number. So our x-intercepts is no solution, which is proven by our graph, as the graph never touches the x-axis. Hope this helps. Had to split it up into 2 videos just to cover the graphing. But any questions, just let me know. Definitely will be doing more videos in the future if you guys found this helpful.